We move on to question 9. Question 9 says, consider triangle ABC where D and E are points on the side AC. All right, so there is no diagram given here. So we have to draw our own diagram. In fact, in Olympiads, very often you're asked to draw your own diagram. You know, at school, you're given the diagrams. So let's read this and draw the diagram. We've got a triangle ABC. And the points AC are divided up into, you've got D and E. Let's put A and C at the bottom so that the points that I'm looking at are on the base. A and C, so this will be B. So you got D and E are points on this, such that angle, these three angles are, you got A, D, and E. How are these points chosen? Angle ABD, ABD. All right, so this angle here is equal to DBE, DBE. So let's draw that. And that's EBC, EBC. So these three angles are all divided up into three equal parts. That this angle, the angle B, is trisected, or it's divided up into three equal parts. So let's call these angles X, 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 right? Okay, it is also given that BD equals BC. BD equals BC. Okay. And AE is equal to BE. So BE is equal to this thing here. BE, AE is this. Let's just put those two. Well, just remember that this line here is equal to that line there. Okay, now one of the things that strikes me, what is the angle BAC? So the question is, what is BAC? This is your question. What is that angle equal to? Yeah, one of the things I was saying that strikes me is that you got an isosceles triangle here, and you got an angle bisected, the vertex angle. Now this is a very, very familiar scene. Whenever you draw an isosceles triangle from the vertex, in other words, where the two lines meet, two equal lines meet, if you draw, either you bisect that, or you draw the median, in other words, you draw it to the middle of this, or you draw a perpendicular, any one of those three things, any one, then all three things are satisfied. In other words, if I draw perpendicular, then this is bisected and that angle is bisected. If I bisect this angle, these two angles are equal and these two sides are equal. Like that. And the reason for that is these two triangles are congruent, you see. You already got two things are equal, a common side, and that. All you need is one more, and then one of these will provide the third one. In this case here, the two sides and an included angle is the reason for congruency. So they are congruent, which means that these two angles here are equal, but they add up to 180 degrees. So the only way you can have that is both of them are 90 degrees. So that is the conclusion. Let me put the conclusions in red. Normally in geometry, whenever I make a conclusion, I put it differently different color from what is given. So the given is all in black, and the conclusion is that these two are equal because these two triangles are congruent. Okay. Now bear in mind that we were told that BE is equal to AE, So this is an isosceles triangle here, BEA, and one of the angles is 90 degrees. So therefore, the other two angles are equal because it's isosceles, and they add up to 90 degrees. So the only way this can happen is that the question mark is 45 degrees. This is 45, and that is 45. And you can calculate all the angles now. But we're really interested on only this angle here. So the answer is 45. All right, so let's go on to the next problem. So there you can see it's 45 degrees. It's the same thing that I said. Okay, we go on to question 10. Question 10 says you got a number which got 2024 digits. Oh, it's a very, very long number. The number of digits is 2024. That is the year in which this paper was written, whose digits are either 1 or 7. All right, so you got a number which has got only 1 and 7 in it. Okay, like 117, 1777711, something like that. But you've got 2024 digits. All right. It is given that the number of occurrences of the digit 1 is 7 times the number of the occurrences of the digit 7. All right, so we don't know how many times 7 occurs. So let's just say let 7 occur, we'll call it 8 times. It says here that the number of occurrences of the digit 1 is 7 times the number of, so then 1 occurs 8 times, because 1 occurs 7 times the number of occurrences of 7. So this number here has got A sevens and 7 A ones. All right. What is the remainder when the number is divided by 9? Okay, so that's that question. I just want to explain something. Division by 9, there is a very nice way of finding remainders whenever you are dividing by 9. All right. Let's take a number like 24135. I'm going to divide this by 9. And I see I've got 2681, remainder 6. You can just check this thing out. Right. Now, you can always calculate the remainder without having to do the long division. When you're dividing by 9. So this is the remainder. Okay. And the way to do that is to add all the numbers. The alternate way of getting the remainder is add all the numbers. You get 15. And add again. 1 plus 5, 6. And there's your answer. You keep adding until you come down to a number which is a single digit. And that will be the answer. Okay, so this is a very useful thing. So all I have to do to find the remainder is to add all these digits. So let's do that. Now, we know that there are A7s and 7A1s. So we can say that the sum of the digits of our number is, okay, you add 7, how many times? 8 times, so it's 7a. And the only other digit that you've got in this number is ones. And how many have you got? You got 7a there also. This is actually 7a times 1, and this is 7 times a. But so the answer is 14a. Now it says here that the number of occurrences now it's a 24-digit number. Oh yeah, okay, that's very important. I forgot this. So you got the total number of digits is 2024, but we know now you got 7 occurs 8 times and 1 occurs 7 times. So that makes 8a. Total number of digits is 8a. So that allows you to calculate a. 8 times a is 2024. So you can calculate a, and therefore your remainder you got 14a, that is 14 times 253. Now you can work out 14 times, this is 506 times 7, so you get 3542. Okay, so that is the sum of the digits. The sum of the digits we saw is 14a, and this is the sum. And then you add again, 8 plus 12 is 14. 8 plus 6 is 14. You add again, you come to a single digits, and that's the remainder. Answer is 5. So you keep adding the digits, and you take the answer and you divide, add again until you come to a single digit, and the answer is 5. Now, I want you to notice that I could have done this thing very much quickly, very faster by adding 1 plus 4 is 5, and take this 2 plus 5 is 7 plus 3 is 10, and 1 plus 0 is 1. 5 times 1 is 5. You could have done this thing for each factor. You'll still get the same answer. Right? Okay, so that allows us to get on to the next question. But before that, let's just check to see whether the answer that I got is corresponds to the answer that yeah, the remainder is 5. So this is the answer that I had advertised. All right, you can read this thing and you probably see it's almost the same thing. So let's get on to the next problem. Yeah, we go to question 11 now. So what does question 11 says? How many positive integers n different from 3 are there such that n minus 3 divides n cubed minus 3? Now, in these problems, there is a certain standard way of doing it. And I want to tell you what you do is step 1, you divide n cubed minus 3 by n minus 3. Now, I don't know I don't know how they teach you long division these days, but I learned it like this. You put n minus 3, and you put n cubed. Now, the n squared, there's nothing there. Put 0 n squared. N 0n, that's the next one. And then here you got minus 3. And you bring that. I try to bring all the powers of n down, coming from 3 to 1 to a constant. Now, then you take your n here, you see how many times it goes into the first one. It's n squared. All right. So now you take this n squared and you multiply it by n minus 3. You get n cubed minus 3n squared. Right. So n squared times this is that. Now you subtract. It's like very similar to the normal way of dividing. When you subtract, the n cubed cancels off because you made sure that n cubed times that these two is equal to this. Now you subtract here, and now it becomes 3n squared plus 3n squared. You bring the next one down, and now you see n goes into this first one how many times? 3n times. n, 3n squared divided by n, the n's cancel, and you have 3n. Now you take this and multiply it. 3n times n is 3n squared minus 9n. 3n times minus 3 is minus 9n. Subtract, that cancels, and you have 9n. You bring this next one down, and once again, n goes into this 9 times, plus 9 times. Now you multiply 9 times this is 9n minus 27. 9n minus 9 times 3 is 27. Subtract, right, that goes off. And minus 3 plus 27 is 24. So that's the, you end it, right? That's the end of the line. You can't divide n 24 by n anymore. All right, now what does all this say? It says that whenever you're doing division, if I'm dividing 29 by 3, I got 3 times 9 is 27, 2. So this 29 is related to the divisor. I don't know, it's a so-called divisor. It's a quotient and the remainder. How it is related? Because this is a remainder, you see. So when I subtract 2 from 29, I'm going to get the product here. So 29 minus 2 is equal to 3 times 9. And you can see 27, 3 times 9. Usually it's written like this, 29 is equal to that times that. No, I'm sorry, that times that, 3 times 9. You multiply those two at the top and add the remainder. So bearing that in mind, here you can do this as n cubed minus 3 is equal to those two multiplied that times that plus 24. Right, now you want to know when you divide this by this, so let's divide n cubed minus 3 by n minus 3. So you get n cubed minus 3 over n minus 3. Right, we want to divide these two. Now when you divide this by n minus 3, you just get the quotient. N squared plus 3n plus 9. And here you have 24 over n minus 3. So I'm dividing every term by n minus 3. Now, I want you to understand this question. Should have said this earlier on. Let's, oh, I put down step 1, but I didn't put step 2 and step 3. Okay, step 2 will be you multiply your quotient and your divisor, multiply the two and add the remainder, and you'll get the original number. This times this plus 2 is the original. That should have been step 2. Yeah, this question says you got n cubed minus 3 over n minus 3. How many positive integers? So you want n to be positive. It's an integer, so it's a counting number, 1, 2, 3, and so on. N is coming from there. So this must divide it. Now let's take take a number like 6. N equals 6. Now you have 6 cubed minus 3 over 6 minus 3. Right? And this, when you work this thing out, you got 213 over 3. And now you see 3 goes exactly into 213, and you get an integer as the answer. So you want to know which values of n is this divides this. So n equals 6. Right? The 3 divides 6 cubed minus 3, because this goes exactly into it. Right? So n equals 3 is accepted. But if you try n equals 5, try n equals 7. When you try n equals 7, you have 7 cubed minus 3, which is 340. 7 minus 3 is 4. And this is also accepted, interestingly. N equals 7. Right? But I think when you try n equals 10, for instance, you got 10 cubed minus 3, which is 1000 minus 3, which is 997. 10 minus 3 is 7. And 7 does not go into this. 7 doesn't go into this. It's 142, remainder 5. So this is not allowed. So the question is, which are the ticks here? Right? When do you get this to be an integer? Now, to make this an integer, that's why I did this. This is already an integer, because the numbers I'm substituting are all integers. 1, 2, 3, 4. So when I substitute these numbers, I'm going to get an integer. So I want this to be an integer. Now, when will this be an integer? This will be an integer provided that n minus 3 is a factor of 24. So n minus 3 is a factor of 24. Now remember that n is greater than 0. So therefore, n minus 3 is greater than 0 minus 3. So n minus 3 is greater than minus 3. Watch out. This thing is greater than minus 3. So you're looking at the factors of 24, which are greater than 3. Greater than, what did I say? Negative 3. Greater than negative 3. Or larger. All right, so let's look at the factors. You see, negative numbers are also factors. Negative numbers are also factors. Like, for instance, you see, factorization means you're multiplying by 2 integers to get your number. 15 is equal to negative 3 times negative 5. And these are integers. So negative 3 is a factor, negative 5 is also a factor. Right? But if you're asking for positive, now you're asking for positive integers, then you allow, this is not allowed. Right? Okay, we've already decided that for that to be positive, n is greater than negative 3. Now, n equal to negative 2 is a factor of 24. Negative 2, negative 1 is obviously a factor. 0 is not a factor. 1 is a factor. 2 is a factor. 3 is a factor of 24. 4 is a factor of 24. 5, 6 is a factor of 24. 8 is a factor of 24. 10 is a 9 and 10 are not factors of 24. But 12 is, the next one is 24. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 such numbers. The question was, how many positive integers are there? And the answer is, I just listed them down. Answer is 10. You might ask, hey, this negative 2 is not allowed. But if you put negative 2 into this, yeah, no, this n minus 3 is negative 2. Sorry. This is where n minus 3 is negative 2. So to get the actual answer, n, you have to add 3. You have to take 3 to the other side. So 3 minus 2 is now 1, you see. Add 3 all the way, and you go up to all the way up to 27. Right. So these all, now you see that n is a positive integer. And we tried 5, remember? And that worked. And when you add 3 to 4, you get 7. And 7 also worked. So 7 is inside this. So the largest one you have is 27. When you put 27 into this, 27 minus 3 is 24. And 24 goes exactly into 27 cubed minus 3. You can check that out. All right, so the answer to this, the question is how many positive integers? These are the positive integers, and there are 10 of them. So that is how you do that problem. So you can see, oh, I've done this thing like this rather complicated way of dividing, but my method of division is, I think, the best way. You still can get to the same answer. And we see right at the end that there are 10 positive integers. Okay, so that corresponds to the answer that I had. So we move on to question 12. Deepak and Kushle are playing a coin picking game where the players take turns to pick coins from a bag. All right, so it seems that there is a bag here somewhere. So there's a bag, and you got a number of coins inside this. So these two guys, they pick coins. So Deepak plays and Kushla plays. All right. Now in each turn, one player can pick at least one, but at most 5 coins. In other words, you must pick, you can't say, I'm not going to play. You must pick at least one. And at most 5. You can pick 5, but you can't pick 6 and 7 and so on. All right. The player who picks the last set of coins is the winner. So the play, he plays. And the player who picks the last set of coins is the winner. Now they say at one stage there are 10 coins left in the bag. And it's Deepak's turn. Right, that's his turn. How many coins should he pick up to ensure his win? All right, now this should be quite easy, because to ensure a win, he has to leave Kushler with oh yeah, I think he has to leave Kushler with so the player who plays last wins, right? So you can't leave Kushler with 5, because then Kushler will pick the whole 5. He's allowed to pick 5, and he picked the last. So 5 is wrong, right? So you can leave Kushla with 4. Oh, wait a minute. And even if he leaves with 4, Kushla will take the whole lot. So none of these are allowed. Can you leave him with 6? All right, you can't leave him with 6, because then once you leave with 6 or more, say he leaves him with 8. And this is Deepak. He leaves, and Kushla now, he can't take more than 5. So he can take 5, but then Deepak wins because he'll take the whole lot. If he takes 4, Deepak still wins because he's left with 4. And if Kushla takes 3, right, now Kushla can take at most 5, you see. So he can't take more than 5. So if Kushla takes 1 from here, then he will take 5 from there. So the thing is, you can't leave him with any one of these. So therefore, he can, from the 10, he must take at most 4. How many coins should he pick to ensure his win? He must pick 4, exactly 4. I think more than that, this fellow can bring it down to 6. So you say Deepak picks 4. Now, whatever Kushla does, Deepak will win because he's going to reduce the 6 by something, by a positive number. And that positive number, Deepak can take completely, and he wins again. But he must not take 7, because if he takes 7, then Kushla will leave him with 6. See? So that's a problem. So all these are out. Okay, so the answer is he picks 4. Right, so that's question 12. Let's go on to question 13. Oh, okay. So I give a very quick answer to this. Question 13. What is the minimum number of points you need to put inside an equilateral triangle of side length 2 to ensure the existence of 2 points whose distance from each other is at most 1 unit? Oh, now this is quite a mouthful. Let's unpack this question. You're starting off with an equilateral triangle. All the sides and all the angles are equal. Right. Now, how many points must you put inside here to ensure that there are 2 points? Okay, I'm going to put in a couple of points. So suppose I put in those 3 points. Now the side length of this equilateral triangle is 2. Right. If I put 3 points, I put 3 points like this. And I want to ensure that the distance between 2 points is at most, to ensure the existence of 2 points whose distance from each other is at most 1 unit. Now, here, if I put this, let me put this a little bit further away. I can put these 3 points quite far apart, and then you will see that you cannot find 2 points. I want to ensure the existence of 2 points. But here, in this case here, I cannot find 2 points whose distance from each other, because this thing is, I see, 1 is halfway through. This length here is 1. Okay, maybe I should put this point here a little bit further away. Put that point quite far away. So here. Now you can see this distance is more than 1. This distance is more than 1. And this distance also looks like more than 1. So you've got, I can put 3 points, and all those, in those 3 points, it's not possible to find 2 points whose distance from each other is at most 1. So it can be 1, but not more than 1. All right, now I can put 4 points as well. Now there's a fourth point. Now if I put the fourth point, it's quite possible that it's going to be that I'll get 2 points which are less than 1 unit. Remember this halfway. Let's just draw the midpoints here. And I'm going to draw a triangle. I'm going to join all these points. You see, you can see the fourth point is going to be a little bit difficult to find here. But let's just join these. Now, I think inside this situation here, it might be possible to find 4 points. In this case here, I think I can find 4 points whose distance from each other. I'll choose 1 point very far away, very close to this. Maybe I'm actually allowed to choose it on the boundary. Choose that. No, they say inside. Okay, I'm not allowed to put those. Okay, let's just remove that. Put this. I can make it very close to it, right? And then now these 3 points are obviously they're almost 2 units apart. Now put the fourth one as far away from there as possible. Let's make it right in the middle. And I think if you work out all these distances from here to there, you're going to get more than 1. If I put this right in the middle, then one can calculate this distance. It's going to be more than 1. But actually, when you put it like that, I think I can actually prove it's more than 1. All these numbers are more than 1. Let's see. See, I want to prove that the distance from here to each of the 3 dots which I've got is more than 1. And the way to do that is drop a perpendicular or join these. Now, if this is right in the middle, if it's right in the middle of this, then you can check to see that this becomes perpendicular. And then you will see that this distance here, the distance from this point to this dot here, right, is almost equal to the hypotenuse of a right angle triangle. And because these are middle here, these are all 1. So this length here is the hypotenuse of a right angle triangle, and the hypotenuse is the largest side. So this is greater than 1. So this distance here should be greater than 1. The same thing applies to those 3 distances. So the long and the short of the story is that I can choose 4 points in this scenario where the distance is where you cannot find 2 points whose distance is at most 1. These 3 together with the middle one. So it doesn't work. So 4 points doesn't work. We want to know what is the minimum number of points you need to put inside there. 4 points doesn't work. But what about 5? Okay, let's go back to this. And let's do what we did here before. Now, when you take the midpoints here, 1, 1, 1, you will see I got 60 degrees. So all these become equilateral triangles. All these will become, it's easy to show that because this is 60 degrees, you see, and you got an isosceles triangle. So all these are all one. Okay. Now, if I look for 4 points, for 5 points, you have to have, you only got four triangles. You have to have two of those points are in the same triangle. That's important. You got 4 triangles, then you got 5 points, and the two of those points will have to be in the same triangle. We don't know which triangle, but there will be 2 points in the same triangle. So maybe you can choose, maybe those 2 points will be like that. And now these 2 points, right, the distance between them will be smaller than, you see, one will be the longest distance you can draw, right, between this. That's not very easy to prove, but you can see intuitively that if you take any 2 points inside the triangle, then the distance between those 2 points will be smaller than the side of the equilateral triangle. So the answer is 5. You need, no matter which 5 points you get here, the argument is that two of those points will be in one of these 4 triangles. And those two, the distance will be smaller than 1. So that way you can ensure the existence of 2 points whose distance from each other is at most 1. Okay. So the only thing that remains is maybe I should do that, is how do you know that if I have an equilateral triangle, and if I take any 2 points inside there, right, that the distance between these two is less than 1. Let's call this side the 1. And if I join these 2 points, how do I know that that distance is smaller than 1? I just made a wild claim that d is less than 1. So we have to prove that. Now I can prove it. It's just meant for the better students here. So try to follow my argument. What I do is I extend this line to meet the sides. This d is less than this because we extended it. So d is less than this full line here. Now this line, it meets these. There will be a triangle formed. And if I join one of these points, you see, when I join this, now you see these two angles here, one of these is obtuse. Because you got two angles which add up to 180 degrees, right? And then the worst you have is both are 90 degrees, but it's that angle is, this is 90 or more. One of these two. But both add up to 180. So I'm choosing this one here. And once I do that, then what I do now is join this to this line. So this line here, because this is obtuse, the largest side in a triangle is opposite the largest angle. So this will have to be the largest angle. So this is the largest side of this triangle. So therefore, this entire length here is smaller than this. See? And this one here will be smaller than 1 because, again, you have an obtuse angle here, and this now becomes opposite that obtuse angle. So you got this is smaller than that line is smaller than this line, and this line is smaller than 1. So therefore, your original D is less than 1. Okay, it took me a while to prove that, but please listen to that and try to understand it. But I think if you just say that the distance is less than 1, intuitively, you can get away with it. But I like to prove everything, make sure that I know why I am saying something. All right, so let's just get on to the next question. Oh, you see, this is the same answer I give here. And 4 points will not work, but 5 will work. But I sort of run through the thing too quickly without explaining what's going on. Okay, we go to question 14. Question 14 says the following. Consider a 6-digit number containing the digits 1, 2, 3, 4, 5, 6. So you got a 6-digit number using those numbers, like 6, 1, 2, 3, 4, 5, right? Without repetition. So we're not allowed to put 2 3s or whatever. All of them must be different. Let IN be the number formed by the first n digits. So I1 is 6, I2, I subscript n, I2 is the number formed by the first 2 digits. So that's 12, first 2 digits. Oh, I'm sorry, 61. And I3 is 612, I4, first 4 digits are 6, 1, 2, 3, I5 is 6, 1, 2, 3, 4, and I6 is 6, 1, 2, 3, 4, 5. Right. So IN is the number formed by the first n digits. Now, it says here it is required that IN must be divisible by n for all n. So you want here now, you want that 2 divides IN. This vertical line is a factor of. So 2 is a factor of I2, 3 is a factor of I3, 4 is a factor of I4, 5 is a factor of I5, and 6 is a factor of I6. And you can see it doesn't work. 2, already this doesn't work here. So as far as I2 is concerned, you have to have the second digit must be even, right? Just bear in mind, because 2 divides this. Now you got I3. Oh no, that's fine. 3 does divide this number here. 6 plus 3 is 9. 3 divides that. So this works here. So as far as I3 is concerned, the sum of the digits must be a multiple of 3, the first 3 digits. I4, oh, this doesn't work because you want 4 to divide this. And now division by 4 means the last 2 digits must be divisible by 4, and this doesn't work. And I5, the last digit must be 5, for 5 to be a factor of that. And here you can see the last digit is not 5. And I6, you have to have 6 dividing the whole source. So now you need to create a number which satisfies all these conditions. All right? So let's just try to create this. Now that we understand the question, we can immediately make some comments. So if you got a 6-digit number, I'm going to draw a 6-digit number. And I'm going to populate this with 6 digits. All right, so I'm going to put my digits inside here. Now remember, as a starting point, if you remember, I had 5 is a factor of I5. So this has to be 5 here because it can't be 0. The numbers you're going to put are 1, 2, 3, 4, 5, 6. So this I5 is this number here which ends in 5. Okay. So I got a 5 here. So now let's have a look at the I3. The sum of these digits, 3 is a factor of this. 3 divides the sum. And the whole 6-digit number, 3 divides that sum as well. So if 3 is a factor of the digits, the sum of the digits here, and 3 is a factor of the sum of all the digits, it means that 3 must be, there's a conclusion you can make, is that these 3 divides that sum as well. I'll put that in red because I know that these two are true. 6 is a factor of this whole thing because I6 is a multiple of 6. The whole number is I6. It's a multiple of 6 is also a multiple of 3. So you've got something to start off with. You got the middle number is 5, and the sum is a digit. Okay, so how can you have the sum of these equal to 5? You could have 1, 5, 6. Right. So the sum of the other two will have to be, if 3 is a factor of the whole thing, the sum of the other two can be 6. So if it is 6, let's do that. These two add up to 6. No, wait a minute. These two can't add up to 1. That's impossible. 5 plus 1 is 6 here, but it can't add up to 1. The next multiple of 3 is 9. Can these two add up to 9? That means those two add up to 4. You can have 1, 5, 4. You could have 2, 5, 3. Oh, I'm sorry, 2, 5, 2. That's not allowed. What am I doing? Sorry about this. Let's start all over again. Okay, I got the middle number is 5. And I got that the sum of these 2 digits numbers, let's call it A and B. A plus B can be, now 5 plus 1 is a multiple of 3, or 5 plus 4 is 9, 5 plus 7 is 12, and 5 plus 10 is 15. So A plus B could be any one of these. But now you get A and B are coming from here, and I already got 5, so I'm not allowed to put in 5. A plus B equal to 1 is impossible. A plus B equals 10 is possible. You can have 4 plus 6. Right. Now, there's another important thing here. You see, I4, this is I4, it's a multiple of 4. So these last two digits is a multiple of 4. So this number here has to be even because these two gives you a multiple of 4. All right, so you got A is even. All right, so suppose now you got 5 and A is even. So A could be 2. They're adding up to 4 now. I'm looking at this one here. I can't have 2 because it's repeated. I can't have 4 this. That's also, you'll have a 0 then adding up to 4. Right. So the only way you can add up to 4 is 2 plus 2 and 1 plus 3. And neither of them works. So this is out. Because 2 plus 2 will get repeated and 1 plus 3, you have to have this as even. Okay. So let's try this one here. They're adding up to 7. This is even. 2 plus 5, no. They're adding up to 7. You can't have 5 that will be repeated. So you can't have 3, 5, 4. Now 3 is odd. You can have 4, 5, 0. So you can have 4, 5, 6. You can have this situation. So like this now, you can try for them to add up to 7. You'll have to have 6, 5, 1. You can have 6, 5, 1. So this is even. You can't have 4, 5. Yeah, you can have 6, 5, 1, or you could have 4, 5, 6. So those three give you a multiple, and this must be even. 2 can't go in here, and you can only put 2, 4, 6 here. So those are the possibilities. So these end like this. Now, what are you going to put here? You got 6, 5, 1. So what goes in here? These two must give you a multiple of 4. Right? 1, 6 is allowed. No, but 1 is already here. So that's out. You want a multiple of 4. You got 16. 36 is allowed. Right? And 56 is not allowed because you got 5 already there. So this is the only number that I can put in front of the 6. I can't put 1 or 3, 1 or 5, because they have already taken. All right. And then in that case, what am I left with? I'm left with 2 and 4. So you could put 2 here. Yeah, so this has to be even. Right? You've taken care of all the odd ones, so this is okay. So you see, this works. So 1 goes into 4, 2 goes into these, 3 goes into those 3, 4 goes into that, 5 goes into that. I can't have that because 6 must be. So this is out. 6 must go into that one. All right, so I'm not allowed to discuss this. I can look at 4, 5, 6, though. And in that case, I have to put either 2 or 4 here. I can't put 4. It's repeated. But I can put 2. And then it's 24. And here, but now you have only 1 and 3 here. So neither of them can be put because you need to have this to be an even number here. So this is also out. Okay. All right. Somehow I didn't seem to find my numbers. But if you keep trying out like this, you will eventually get to the number that you're looking for. So there it is. These two are the we actually found two numbers. Both of them end in 654. Why did I eliminate 654? I had 654. Oh, I had 456, but I didn't have 654. That's a mistake. I could have put it 456 was out, but 654 is allowed. That's the one which I didn't try. And there now you see you have two numbers with 654. All right, so there are only two numbers which satisfy this condition. An interesting problem. Okay, so fortunately I had my answer, and that is my answer. Let's get on to the, oh no, this, fortunately we are at the last one, question 15. There are 15 questions in this team competition for juniors in the individual, and we are at the last one. Now, here the question is, you got to figure, fortunately they drew this figure for you. The area of the square ABCD is 625. So the area, let's use my black, area ABCD, 625. But the area of the square is a side squared, and this is 25 squared. So the side of the square is 25. So they give you that ABCD has got area 25, and the area of the rhombus. Now, oh, this is the rhombus. It means all the sides are equal. But the angles are not 90 degrees. The area of the rhombus is 500. So you got 500 is the area of the rhombus. And the area of a rhombus or area of any parallelogram is base times height. Right? And the base is, okay, we saw the base is 25. The rhombus shares one side with the square. So the rhombus will also have sides 25. So this is 25 times the height. So the height must be 20 because it's 500 divided by 25. 100 is 5 times 100. 25 goes into 100 4 times. 4 times 5 is 20. I do a lot of cancellation to make my calculations faster. So the height is 20. But at the height, I can actually see the height here. The height is dg. So this is 20. And this part here is 25. Because it's the side of the rhombus. So you got to, this is 90 degrees because all these lines are parallel. So I got two sides of this right angle triangle. This is 25 and that is 20. So I can work out what that is. So GF squared, I'm not even looking at the question, I'm just trying to get as much information as possible. GF squared is the, it's in a right angle triangle, you've got two sides there. So there's 25 squared minus 20 squared. Now, I don't work out the whole, I don't square this and find the square root. I can do this very quickly because this is the difference of two squares. Right? Try to, in Pythagoras, there is a difference of two squares that occurs, and that helps you to make calculation very quickly. So this is 25 minus 20 into 25. So 25 minus 20 is 5, and 25 plus 20 is 45. So if you take out one of the threes from there, you get 15, and divide this by 3, 15. So GF is 15. Okay. So if GF is 15, the whole thing here is 25. So this part here will be 10 from E to I. Okay. Now they ask you, what is the area of the shaded region? Now I'm looking at that to see what the question is. The shaded region has got a funny shape here. So let me make that into two recognizable shapes. And the way to do that is to just extend this line here. And that creates a rectangle and a triangle. And so the area that we're looking for is a sum of these two areas. Okay, so do I know the area of the rectangle? Okay, I know one side. So do I know the other side? This side here is CG. Yes, of course I know it, because CD is 25 and this is 20. So CG must be 5. The whole thing is 25 and this part here is 20. So this part there must be 5. And therefore the rectangle has got sides 5 and 25. So the area of the rectangle is 5 times 25, which is 125. Now let's look at this triangle. Now, the area of a triangle is half base times height. I have the height already, that's 25. The base, do I have the base? Well, I've got 10 here, and the whole thing is 25. So this will have to be 15. So it was useful calculating all these other lengths here. So this part here is 10. The whole thing is 25, the opposite sides of a rectangle. So this is 15. So the area of this triangle is half base times height. Oh, wait a minute. The height of this is not 25. The height of this triangle is 20. That's 5 and this is 20. So the area of the triangle it's a right angle triangle. And so it's very easy to calculate. It's half base times height. So it's half times 20 times 15. 20 times 15 and multiply them, and that's 300 divided by 2, 150. So the area of the parallelogram is 125. So the required area is 125. That's the area of your rectangle, plus the area of your triangle, which is 150. And that gives you 275. Square what? Oh, it's given here centimeters. So it's square centimeters. Area is always in square units. And the units are given as centimeters. So you'll write that down. So the answer to this question is 275. Okay. Let me just check to see whether that's the answer that I got. Oh, there it is. So I got the same picture. So that, guys, brings us to the end of 2024 team papers. We'll make sure you could check the other ones. I've also worked out the 2023 and 2025 team papers. And in addition to that, I worked out all the Maths Olympiad problems, South African Mathematics Olympiad problems, rounds 2 and 3 junior from 2023 to 2025. So you've got lots of worked out problems. Go into the site www.samf.ac.za. That's the South African Maths Foundation website. And I think there you will find all the solutions. Okay, otherwise it might be on YouTube. I don't know. Okay, so that brings an end to this session. Enjoy the rest of the day.